All right, good morning, everybody.
Morning.
Wow, 11 people here. Attendance in this section has really dropped off. It's kind of interesting because the morning section is holding really strong. But numbers in here are dropping. But you're here, so that's good. All right, any questions? All right. Well, a few announcements. So first of all, I mentioned in Canvas yesterday that I'm not going to do SLP presentations for this quarter. So everybody has got 25 out of 25 on the presentation portion of the service learning project. And the main reason is, number one, Izad is not doing presentations in his classes. And normally we put the two classes together, so the engineering class and the CS classes present at the same time. And so we'll do that in winter. We'll have his 252 class and CSE222, and it'll be a big expo with people presenting their winter term progress on their SLP. But for fall quarter, I would rather use the remaining class time to talk about more things related to Unix and programming. So you've got 25 out of 25 for the presentation part of the SLP. You still need to upload your poster. That's half of the SLP grade. So make sure you upload that PDF by the deadline. The upload button is there. It wasn't there over the weekend, but it popped up last night.
Will the winter presentation be early on, or will it be at the same point it would have been?
It'll be probably the last Tuesday of the term, so yeah, same point as this would have been. So it'll be the progress for 2 quarters of working on your project.
Oh, and I do have a question for the SLP poster.
Okay.
Is it how's it graded on? Because as long as it fills out the requirements, we're all good to go.
You're probably good to go as long as it fills out the requirement. If you turn in the poster and you have one sentence for each section, I'll come back and ask you, like, did you do more than this and so on. But yeah, basically just, write a few sentences or a paragraph for the different sections. If you have initial designs and such, you can put those in there and so on. But yeah, it's usually just a part of the presentation process.
Okay. So it's kind of like we're taking our proposal and just putting it in the form of something we can present.
You're taking your proposal and your progress so far, right?
Yeah.
And the main progress for fall is, a more polished proposal of what you're going to do in winter and spring. So not necessarily going to have results, or block diagrams or schematics or things like that. But yeah, it's basically just a presentable form of everything you've done so far.
Alright, thanks.
Yeah. All right. You should also be seeing on Canvas a like a customer satisfaction survey for this class. So every year the school picks one class for teachers and sends out through Canvas a survey of questions about your experience in the class and so on and so forth. And it should not take too long to do those, so please try to do that. We've got about 46% participation right now. If not enough people respond by the end of the course, then they have to do this again with another class, and so on and so forth. So it's not something that I have any access to until after grades have been submitted. So later in December I can go and I can see, the synopsis of the comments. It's anonymized to whatever degree, but I don't have any access to any of the information on that other than the percentage of how many people have completed it, so that I can come in and ask people to try to do it, which is what I'm doing right now. So if you can take a few minutes sometime, sooner rather than later's easiest, so you don't forget, and just make sure you do that survey. That would be appreciated. And it's something you want to do, right? Because it helps course correct instructors, and if there's issues with classes, it's a chance to talk about those, and those things are taken seriously. Um, they get used and applied to hopefully improve the teaching and the classroom experience here at Clark. So definitely do that.
It's weird. One of mine was like my lab teacher. It's like I really don't know anything about
Yeah,
it.
yeah.
He made good announcements, I guess.
Yeah, so I mean, I think it's probably fair to mention that somewhere. Sometimes they have spots where you can just sort of freeform comments, and that's totally legitimate. Like, I don't interact with this person and so on. It's kind of like when a student asked me for a letter of reference, and I've like never met them, and I've had them in a class, but they haven't turned any assignments, and it's like, so what can you say? All right. PA5. Let me just make a suggestion. If you're still kind of stuck on PA5, or you haven't gotten started yet, or you're not sure what to do, two things that you can do in the beginning of PA5. One, which we've kind of like talked about as the first step, is dealing with the input. So write something that reads a line of text, cleans it up, breaks it into phrases, and then maybe just goes through a loop and prints out each phrase. And you can do that, independent of counting how many times the phrases occur, just as an experiment, right? To see if you can process the input the way that you want to. And then, the second part is, after you've got these individual phrases, trying to count those up. If you want to change gears, if you're kind of stuck on the parsing piece of this, or if you're done with that and you're trying to figure out how to do the tallying part, right? You can do a kind of standalone practice version of tallying input. And so you could write a script that basically just reads, a word from the user, and then records that word in an associative array, and set up a program that you run it, and it basically lets you type in hello, enter, type in goodbye, enter, type in hello, enter, type in hello, enter, type in cool, enter. And when you're done, hit a control D and have your script tell you how many times each word appeared. And this gets you using the associative array, but in a pretty streamlined form, right? You basically read input from the user stored in a variable, just say, array bracket that variable equals array bracket that variable plus 1. And so it gets the associative array piece, it gets the incrementing the tally piece, and then at the end, your for loop, where you go through all the indices in that array, it gets that piece of it too. And so if you're stuck with the associative array part, right, you could do something like that, and get that piece of the code working, and then really just sort of glom those two together, and that's PA5. Except instead of tallying words that you read from the user, you tally the phrases that you get from that first part.
And are you going to run PA5 on your local computer, or are you going to try to run it through the server?
I'm going to run it on the server.
Okay.
So
like I said in my email, I had a long delay for test 4.
Mm-hmm.
But when I ran it on my local computer, it took like a minute. And when I ran it on the server, it took like 19 minutes.
Oh, interesting. Any chance you're parsing the entire file as a single line of input?
I don't think I sent you the code.
Oh, you
I
did.
I emailed it to you the other day.
Yeah. Let me make a note.
So if you can see something there that's wrong or that could be done better, but I'm pretty sure I'm reading each line, cleaning it up, and then passing it to a for loop as it should be, hopefully.
Yeah. All right. I wrote a note to myself. I'll go take a look at that.
Okay. Yeah, everything else runs in like a small percentage of a second, for the other little tests. But
Okay, cool.
the other one just takes a while.
Interesting. Yeah. Well, I'll test these on the server, and usually, I have multiple windows going where I've got someone's test 4 running in the background while I'm testing someone else's code on test 0 through 3 and so on. So it's an exciting Thanksgiving.
Yeah, that sounds like fun.
Definitely. Were you calculating the density of the moon before?
No, it's just a joke.
Okay.
Whenever my computer runs slow, I think like, oh man, someone's calculating the density.
Yeah, exactly. Cool. All right. And yeah, so there was some conversation in Discord last week, and where somebody was SSHing from one machine and getting different sort outputs from if they SSH from a different machine, and it turns out that is a thing. There's this notion of locale, which is regional information. And apparently when you SSH by default, information about the locale on the machine you're coming from is shared with the machine you connect to. And sorting with the -n switch to sort numerically does different things depending on your locale. And so somebody was coming in from a Mac and getting one result, and coming in from another machine and getting a different result. And apparently you can disable sending locale information in SSH, and then if you do that, it works. So yeah, I didn't know that was a thing, but that's kind of cool. That would be a really, really evil final exam question. I won't ask you that, but that would be cool.
And as long as like everything's saved on the server, it should run independently, right? That shouldn't have any effect on your, like, how bad your internet connection is, like you said.
It shouldn't.
Right.
How bad your internet connection is shouldn't affect it, but this locale thing definitely does.
Yeah.
Yeah. But you're not required to sort PA5 anyway. That's just for making it easier to look at the results and compare it to my results. So that's not an issue. All right. Well, let's talk about awk. And bad internet connection should not affect how quickly it runs. If it has to print to the screen, that could affect it. But for PA5, that would just be at the very end. And once it starts printing, then you know it's done. So we've been using awk like this. Just a way to pick out, a word from a line. So if we want to print out the second field on an input line, we can just print $2. And I suggested this in PA4, for example, if you wanted to print out the month of a date where it's written, month/day/year. We could do awk dash and say separate our fields by slash instead of space. And let's print out the first field. And now if I say December 25th, 2021, it prints out that 12, that first field. So that's pretty much the extent of what we've done with awk so far. And that's possibly one of the main uses you'll make of this tool. But it can actually do a lot more than that. And so awk is a whole programming environment. And so awk is gawk. It's the GNU version of awk, but it basically functions the same. And the general way we use this is as follows. We say awk space. We list a program, space, and we list a file. And the idea is awk will execute this program, right? It's an awk program on the contents of this file. And so when we say something like, awk, quote, print $2, we're saying, okay, here's the program, print the second field. And like everything, or most things in Unix, right, if you don't specify a file, it just reads from standard in. which lets you redirect standard in or pipe a command into another program and so on. But if I say something like, you know, print $2, and I just look at my bash RC, this will print the second word of each line from my bash RC file. So this last one is an alias, and it didn't print the word alias, but it printed the second field. And the fields are separated by spaces by default. All right. If I have a very complex program, if I have a simple program like this, right, which is just, you know, print $2, I can just specify that on my command line. But if I have a more complex program, I can say awk-lowercase f and the name of a program file, so just a plain old file containing an awk program, and then I can list my input file over here. And so we'll do both of these. And so the basic structure of a program is a set of lines, and each line looks like this. There's a pattern, a curly bracket, and some action. And our awk program is just a collection of lines like this. Pattern followed by an action. And the basic setup is you read a line of input from a file or from standard in, and you check to see if this pattern matches that line. And if it does, take this action. And then go to the next line of your program, see if that pattern matches, and if it does, take the action, and so on and so forth. Process the entire program on that first line of input. Now read a second line of input. And if it matches, you know, this pattern, take the action, next pattern, take that action, and so on and so forth. When I didn't sort the test 4 output, it ran through PA5 in about 1 minute 58 seconds. That's a reasonable time. It's strange that sorting would take so long, though, because I thought that was pretty fast. But if PA5 is going in 2 minutes, that's respectable. All right, so these patterns, these are things that are used to investigate each line of input to see whether the input matches that pattern or not. So there's a pair of special patterns. There's a pattern called begin, and begin matches our input before we start reading any input. So it's a way to do some initialization in the beginning of an awk program. And end matches our input after we're done reading input, after we've read the last line of input. And so it's a way to do some sort of deinitialization at the end of processing. So those are special patterns. All right, there's also variables. So the main variables we use are $1, $2, $3, etc. And these represent the first, second, third fields on an input line. Where a field is defined by whatever your separator is. Your default separator is a space, but you can also put in a switch -F and list a separator character.
Is that limited to like one character, or could you do?
I think it's limited to one character. I'm not positive.
Okay.
If you wanted to separate on multiple characters, you could run your file through sed first, or tr, change all of the possible separators to one separator, and then do a -F separator. But it may have some capacity for more complex things in awk itself. All right, $0 gives you the entire input line. So all the fields, $1 through whatever the last field is, separated by spaces, or whatever your separator is. There's also a variable called NR. This is the number of records. This tells you how many fields, how many records you've input from the input file, so the number of lines that you've read. And then NF is the number of fields, how many separate fields you have on the current input line. so let's play with this. So I have a data file I'm going to mess around with. This is called foods, and it's a set of 4 tuples. So it's a name of a food, a category of the food, a color, and a relative price, whether it's cheap or expensive. Oh, yeah, so general comment, the server was lagging last week. There were a few jobs that were running from a few weeks earlier, and were taking up some CPU time. So I cleaned the server up over the weekend, got rid of runaway jobs, and I think that sped up some people's tests. So yeah, if you were getting slow time last week, try it again this week. All right, so here's a sample file, and if we just want to see, you know, the foods that are contained in here, I could just print $1 from foods. There's a list of the foods. If I want to see the types of foods contained in here, I could just print the second field. And we could do a lot of basic processing just from bash, right? If I wanted to see a list of different types of foods, I could take this and I could pipe it into sort to put it in order, and I could pipe that into unique, and that would show me a unique list of foods, and I could do unique dash count, and that would show me the number of times each type of food appeared, and I could put that into sort dash n and get a sorted list of foods and how often they occur. And if I wanted that list to go backwards, I could pipe it into tac, which is cat but backwards. And now I have a list of my most popular type of food down to my least popular, right? This is all just bash, you know, one awk command and then just a bunch of bash. And so even if you don't know a lot about awk, right, if you know bash and you know how to pipe things and you don't mind playing this puzzle game of what pieces should I put together, right, here's a whole batch of commands put together to do this kind of thing. We'll see some other ways to do this in awk itself. But, you know, it's all Linux, right? It's all stuff that plays together nicely. All right, so let's look at some programs in awk. This is one program, right? Just print the second field. If I wanted to just, you know, get the contents of my file, I could do this. Well, this is just a glorified version of cat. I'm just saying for each line of input, print out the entire input line. All right, so let's make a bit of a program. Here's a program called FF. It's basically 3 lines. There's a pattern called begin, which, you know, will always match before I start reading inputs. So this will happen at the very beginning, and there's a pair of print statements. Print out food and type with a space, print out some dashes to look like underscores. And then on every line of input, there's no pattern specified here, so this action will always take place. And the action is print out the first field, a space, in the second field. So I'll print out the name of the food and the type of the food. And then when I'm all done, the end pattern will match, and the action is just print out goodbye. So if I do awk-f, which says read your program from this file, ff, and then process this file of input called foods, right, I get a nice little subset of my input file where I've broken it into 2 columns of interest, the name and the type of the food. And at the end of all of that, I just said goodbye, but, you know, I could do something else there if I wanted. All right, I could do a different program like this. I'll print out a header for the beginning with name, type, color, cost, but I'll also put an extra field in the beginning. I'm just labeling it number sign, and my action on every record is going to be to print NR, right? And remember, NR is a special variable. It tells me the number of records I've read so far. So I'll print out the number of records I've read, a space, and then $0, which says the entire input line. And so each row of my file, I'm going to print out a line number, basically, followed by the line. Right, so there's my original file, but with a line number in the beginning. And then I had a pattern at the end which says print the total number of records, NR, and so at the end it told me, hey, you got 17 records. And so this is a quick and dirty. Right, if I want to print a file with line numbers in the beginning, I could just do this, print NR, comma, $0, and there's my bash RC file, but with line numbers in the beginning. There's other ways you can do this. There's other utilities that could do this. You could do this in bash, it would take you a few lines. You could do it in C, it would take you a few more lines. It's a one-line program in awk. So there's always kind of a tension in learning Unix, which is how much should I learn? And you know, if you spend all your time learning new commands, you don't get very good with any of them. But at some point, if you don't learn enough commands, you're at a disadvantage, right? So awk and sed, which we're talking about today and tomorrow, for me, have been commands that as I do more and more in bash, they become kind of indispensable, right? Being able to do this instead of writing a C program to add, you know, a line number and increment it on each line has been worth learning awk. So, you know, this is just something to have in your bag of tricks. All right, so here's a different program. It's got a begin pattern, which just prints out a header. It's got an end pattern that says goodbye. It's got a single line in the middle. And so the pattern here is length of the first field is less than or equal to 4. So it's going to read a line. It's going to look at the first field, the stuff before the first space, and it's going to see if it has 4 or fewer characters. And if it does, it'll say that line matches this pattern, and it will take this action, which is to print out the name and color of that particular food. So this prints out foods whose names have 4 or fewer characters. And again, if we're just trying to print out, you know, we're printing out a header and a trailer here and so on, but you know, this will read a line of input, see if the first field has a length bigger than 5, and if it does, it will print out the entire line. And so that's a quick way to subset my file by, you know, in this case, foods that have 6 or more characters in their name. You can do this in C. You have to do some kind of scanf, and you have to, you know, make sure you got a first record, and then check the string length, and if it's bigger than or equal to 6, then you can go ahead and print out the line that you read, and you need temporary variables and all this kind of stuff, right? Awk, it's one-line program. And you know, if I run this from standard in and I don't have any input, it's not a problem. If I decide to check, you know, for the second field, and I don't have a second field, it's not a problem. So it's a better suited to rapid development kind of environment. It's more forgiving. You don't need to compile it, and so on and so forth. All right, there's another kind of pattern match we can use, which is a pair of conditions, condition 1, comma, condition 2. And here's basically what this does. Let's say these are the lines of your input. So awk will start reading your input file, and it will check each one to see if condition 1 is true. And let's suppose that condition 1 is true on this line. It will continue reading, and it will only check to see if condition 2 is true. So it will check this line, this line, this line. Let's say on this line, condition 2 is true. All right. Your pattern, this pattern here, will match all of these lines. It will match the first line where C1 is true, and it will match the first line after that where C2 is true. And then it will cease to match until you get to another point where C1 is true. And it will match that line, it will match all the lines up to and including where C2 is true, and then it will stop. So if you wanted to pull out blocks of code from a C program, we could ask, if the input line contains a curly bracket, and if the input line contains a closing curly bracket. And this would print out, everything from the first line where there's a left curly bracket until it finds a line with a right curly bracket. And then it will stop printing until it finds another line with a left curly bracket, and so on. But the main way we use this is probably just to subset a file between two line numbers. So if I say something like number of record equals 10, comma, number of record equals 20, and I put some action here, this action will be applied to records 10 through 20 inclusive. Because when it gets to record 10, this condition is true. It starts matching the pattern until this condition is true, record 20, and then after that, the record won't fire. So if I let's put line numbers back on my bash RC. All right, so there's my bash RC with line numbers on it. I could say awk number of record equals 360, comma, number of records equals 366. And let's print out the record number and the line itself. This should print out 7 lines from 360 to 366. So it should print out export pager equals all the way down to Java home equals. All right, so there's our output. So you got a file and you want to see what's, between two lines in it, you can use something like this. And again, one line program. All right, awk also understands regular expressions, and so we can say something like, $1 tilde slash some regex. And this, as a pattern, will basically say, look at field 1, see if it matches this regular expression. And if it does, the pattern is considered a match. And so an example of that might be this. So I'm going to look at field 4, which was the price of the food, and I'm going to see if it matches the regular expression cheap. Well, it's not really a fancy regular expression, it's just 5 characters, right? So if field 4 matches cheap, then what I'm going to do is say set field 4 equal to under $2. Otherwise, set field 4 equal to over $2. And then regardless of the condition, let's print out $0. And so this is a program that itself has no pattern, has no begin, has no end. It's a single action to be applied on every statement, every line of input. And it's just a plain old if-else statement. So check field 4. If it's cheap, change it. If it's not cheap, change it to this, and then print out the entire line. So now I've got my original foods file, but this last field that used to say cheap or expensive has been changed into, you know, a phrase. We can have variables, so I can say, you know, set cheap equal to 0 and expensive equal to 0. And we don't have to declare these, we don't have to say that they're integers or whatever, right? We don't actually even have to initialize them, but since I've got a begin pattern that I can use, this will set these things to 0 before it processes any input. And then it will go ahead and see if that fourth field is cheap, and if it is, it will increment the value of this variable cheap. If it's expensive, it'll increment the value of this variable expensive. And then at the end, after all processing has been done on the input, I'll do a pair of print statements. And these look like C print statements with %d and \n. They work exactly the same way. So I'll print out my variable cheap, you know, next to the word cheap foods, and expensive next to expensive foods. And so this will give me a tally of how many records had that fourth field matching cheap or expensive. So there we go, 11 cheap foods, 6 expensive foods. We could also do this in bash. We could run this through sed. We could take that everything up to the last space and get rid of it. And then we could grep for expensive. And then we could put that through word count and find out, you know, we got 6 expensive foods and so on. But this is pretty easy to concoct once you're comfortable with awk. All right, awk also understands arrays, and in particular, it understands associative arrays. And all of the arrays we use in awk are basically associative. General array is really just a special case of an associative where you just happen to use, you know, integral indices starting from 0 going up to some number. So here's a cool little program. Foods bracket $2++. That's the whole program. There's one statement, one action that fires at the end of all the processing. But foods bracket $2++. So what does this do? So let's say we have orange, which is a fruit. We have Oreo, which is a cookie. We have a banana, which is a fruit. We have coffee, which is a drink. All right, foods bracket $2++. All right. We're not declaring foods to be an array. We're not saying it's associative. But as soon as we use this thing called foods with brackets after it, awk says, oh, that's an array. And it does whatever has to be initialized internally to make this thing work like an array. So we read the first line. This is what $2 is going to be, right? $2 is a second field. So this one statement basically says foods bracket fruit ++. All right, well, foods is a brand new array. There is no entry for fruit. And so foods bracket fruit is basically an empty line. But just like bash, when you try to increment an empty line, it turns it into a 0, and when you increment it, it will set it equal to 1. And so after that statement, foods bracket fruit has the value 1. All right, now we read the second line, and this says foods bracket cookie ++. All right, because $2 is cookie. And the current value of foods bracket cookie is 0, and it increments 0, and that turns it into a 1. And so foods bracket cookie equals 1. Now we get to the third line of input, and again it says foods bracket fruit ++. Well, it reads the current value of foods bracket fruit, That's a 1. It increments it to a 2, and so this is a 2. And then on the fourth line, $2 is drink, and so foods bracket drink doesn't exist. It's a 0. We increment it, it sets it to a 1. So at this point, we've read 4 lines of our input, and we have an associative array named foods that, guess what, tells us the number of times each type of food appeared. Right? So this is your tally program for PA5, right? Except you're doing it in bash. And you're doing it on phrases instead of fruits. And if you did this, if you did awk arrays for PA5, that's okay, but make sure you know how to do associative arrays in bash, because those will be on the final. So make sure you can do it in bash, and if you sped it up by using awk, that's okay. All right, so this will read all of the lines of input and tally them up in this foods array, and then at the end of all the input we have a for loop, and this is like the for loop in bash. It's a for in statement. So for food type in foods, which means iterate over all of the indices that we know about. So this will iterate over fruit, cookie, and drink. And in no particular order, food type will be set equal to one of those, and then the next, and then the next. And for each of those, do whatever's in the body of the for loop, which for us is a single print statement, which says print number of %s, which is food type, the index name, colon %d, which is the actual tally, foods bracket food type. So if I run this on foods, it tells me, hey, you had 1 meat, 2 vegetables, 5 drinks, 4 fruits, etc. If I wanted to tally instead of just the type of food plus the color of the food, I want to know how many yellow fruits there are, how many orange fruits there are. It's exactly the same program, except when I index my associative array, I'm indexing it with $2-$3. I'm making a new index, which is a composite of the second field, the type of food, and the third field, the color of the food. And so if I run this, it tells me I've got 1 green vegetable, I've got 1 yellow vegetable, I've got 2 yellow fruits, and so on and so forth. All right, here's a slightly different program. So this is going to read a line of input from a file or from standard in, but it's going to run a for loop inside there, and the for loop basically says for item equals 1 up through NF. And remember, NF is the number of fields that we have on the input line, the number of things separated by spaces. And so this will basically go through each piece of the input, each field of the input, and item will go from 1 through n, where n is the number of the last field. And here I'm saying counts bracket $item plus plus. So counts bracket $1 plus plus. Well, $1 is the first field, so whatever's in that first field, counts bracket that thing will get incremented. And whatever's in the second field, counts bracket that thing will get incremented. So if my first line of input is something like this, is a test, this for loop, right, will execute 4 statements, because NF is 4 fields. The first one will be counts bracket this plus plus, and then counts bracket is plus plus, and so on. And so just like the food types, right, this is tallying how many times different words appear in my input. And it will do this across all lines of input, and then at the end it will do a for in loop, go through my counts array and print out the index stored there, that's the %3d, and then print out the index itself. So I type in some random input here, and this gives me a tally of words. It occurred 2 times, occurred 3 times, test occurred 3 times. All right, I can use the same program in a different way. I can make a script. And normally when we make a script, we say /bin/bash in the very beginning. But in this script, I'm putting user bin awk, which is where awk is stored, user bin awk. And so the shebang says user bin awk -f, which means, you know, read a file for the program. And so if I just run this program, if I just say index, it's not bash that's going to try to execute each of these statements, it's awk. And so I've got, you know, my word index program stored inside this file, and to run this, all I have to do is say index. And it runs my awk program. So if I take War and Peace, which is, you know, 3 million characters, 63,000 paragraphs, I can say index War and Peace, and there's my word index. That's how many times each word appears. And if you want to see the most common phrases, we can put it through sort-n. And so these are the words that occur most often. And most of them are, you know, just short little words, adjectives, pronouns, things like that. I could pipe that into grep. Search for a colon followed by any 7 characters, so none of these lines will match that regular expression. But any line that says colon followed by at least 7 characters will, so now I can get, you know, a frequency count on long words in War and Peace. So you can do stuff like that, right? And it's, you know, a 3-line awk program, basically. All right, and then finally I want to mention that just, you know, we don't have to do input processing. Awk is a full programming language. So here's a program that doesn't do anything with an input file. It just has a begin statement. And it says, you know, let's do a for loop, x from 0 to 10, let's print out x. And if I just do awk-f s1, you know, it's a quick way to do a for loop. Here's a program that adds the integers from 0 through 10. And if I just do awk-f s2, it tells me the sum of the first 10 integers is 55. Here's an awk program that generates prime numbers. So I have a for loop from 3 to 1001 by 2, so that's the odd numbers. I have a composite flag. I iterate through odd numbers up to and including the square root of the number I'm testing. And I increment by 2, so b is a possible factor. If a is divisible by b, I set my composite flag. At the end of that loop, if I haven't set the composite flag, I print out my number a, which should be a prime number. And if I run that, there's a list of prime numbers. And no compiling, no funny, you know, curly bracket, space, dash stuff in bash, right? This looks and feels a lot like writing C code. I don't actually need the semicolon there, that was just a habit. But, you know, there's a prime number generator. So awk is a good go-to, right? It's something to play around with, something to know the basics of. But mostly something to just remember it exists. And as you're working in Unix, if you find, you know, you want to partition a file into records between 2 lines or something, right? Think back, oh yeah, there was something about awk where I could do that. If you got time, go back to your notes, review it, and maybe you'll find something that's useful. So go with that. All right, send me an attendance ping, please, and we will call it a day for 224. We'll go through SED tomorrow, and then that's it for the week. So we'll go through SED as a programming environment, and that should do us. All right, have a good one. I will see you all next time.